Hi and welcome to today's lecture. Today we continue with our journey through bivariate methods and focusing on the case of two quantitative variables for which we have a few methods. In other words, these methods are applied to data on two quantitative variables, namely covariance, correlation, scatter plot, and simple linear regression model. So recall that we have two quantitative variables, namely x and y. X and y are quantitative variables. So x is one quantitative variable, y is another quantitative variable. And when we calculate the covariance of x and y, covariance can be positive, can be zero, can be negative. And covariance can take values from minus infinity to plus infinity. If covariance is positive, this is a sign of direct relationship. That means if x goes up, y is also going up. And the other way around is also true. If decreases x, y is also decreasing. And if covariance is zero, which is in practice not happening that much, then there is no linear relationship between x and y. And if covariance is negative, there is a direct relationship between x and y. That means if x increases, y decreases, and the other way around is true too. If x decreases, y increases. The task one for you guys would be to complete this table. In other words, based on the value of the covariance, please write here whether we have a direct relationship or indirect relationship or no linear association. Please remember that covariance is basically used to test the linear relationship between the given two quantitative variables. However, it doesn't give us how strong or the information how strong the correlation is or the relationship or the linear relationship is. The only information it gives us is whether the relationship is direct, indirect, or there is no linear relationship. A better kind of methodology or measure is correlation. Correlation is actually not only giving us the type of the relationship, whether it's direct or indirect or no, it also gives us the strength of the linear relationship, how strong the relationship is. Correlation takes values in the interval from -1 to +1. So obviously somewhere in between there is 0. So correlations which are between 0 and -1, they are showing negative or indirect association. Those correlations which are between 0 and +1, those positive correlations, they are signs of direct relationship or direct linear association. Now, the more closer the value of correlation is to +1 or -1, the stronger is the relationship. Stronger is the relationship. So here, for example, for the correlations which are close to -1, we have a strong indirect relation. For values close to +1, we have a strong direct relation. On the other side, the more we get closer to 0 from both sides, the strength of the relationship actually decreases. And in this table, we are giving a kind of rule of thumb on how strong the relationship is based on the value of the correlation. For example, if you look at the values from 0.9 to 1 or -0.9 to -1, we have very high positive or negative correlation or linear association. On the other side, if we have values from 0 to 0.3 or 0 to -0.3, then we have negligible or very weak kind of linear association or correlation. And task 2 for you guys would be to write in this table in the second column whether the relationship is direct or not based on the value of the correlation that's given here. That you can do or you can write based on the sign of the correlation and how strong the correlation is. And that's actually where you have to use this table. The closer the values are to +1 or -1, the stronger are the relationships. The closer the correlations are to 0, the weaker are the correlations. Of course, 0 is negligible or no linear association. Then we have a graphical method to check the amount of linear relationship between the two given variables. These graphs are called the scatter plot. Normally you put your x variable on x-axis, your y variable on y-axis, then you plot the scatter plot. And you see here that the dots are exactly on the same line. This is a perfect positive correlation. And here you see that not all points are on the same line, but they're very close. This is a strong positive correlation. And you just see that if you draw a line here, the points are away from this line. Therefore, this is a weak positive correlation. And here, though, there is no correlation, because if you put a line here, nearly all points are away from this, and there is no line fitting to these points. Therefore, this correlation is actually very weak, or no linear association, or no correlation, or nearly zero correlation. And the scatter plots down here, you see have weak negative, strong negative, and perfect negative correlation. Perfect negative correlation means that correlation is equal to -1. For perfect positive correlation, correlation is actually equal to +1. And then for a strong correlation, you have bigger than 0.7 correlation. Here you have minus 0.7, less than minus 0.7 correlation. Task 3 for you guys would be to write down whether you have positive correlation, negative correlation, or negligible weak correlation. For example, in here you have a strong negative correlation, and here you have no correlation, and here you have a strong positive correlation, here you have nearly no correlation, and so on and so forth. So please check which graph or scatter plot is representing what type of correlation and how strong that would be. Then we will be having a simple linear regression model. Simple linear regression model is nothing but representing the relationship between y and x as a linear function in the form of y is equal to a plus b times x. As you can see, this is a kind of the equation of a linear function. What we do here is, if correlation is moderate or strong, we can model the relationship between x and y using a linear function, where we put our x variable on x-axis and y variable on y-axis. We try to model this relationship using this linear function, and for that, obviously, we need to find the value of a and the value of b, and that's being explained in this video on SLR, which I will share on Canvas, so please check that one as well. It's not only estimating or finding the value of a and b, but it also further exercises, further applications that we can do using this simple linear regression model, and that's being explained everything in that video on simple linear regression model that I'm going to share on Canvas.